Good day. I thought of speaking of tools on the occasion of this symposium on Bionics Today. It all started with an experiment showing that people automatically converted vibration that they felt, and which depended on time, into a percept of location in space. They did this spontaneously and without training from the vibration signature of a ball rolling under the action of gravity. Of course, they use prior information about the mechanical invariance of the world. But could there be some more general principle behind? Here, with a group of Alessandro Farney, we noticed that people could tell, also spontaneously and without training, the location of impact on a wooden stick. Could tools be sensorially embodied? This hypothesis is in contrast to previous accounts that proposed that sensations are distalized or projected through a tool. Since Leonard Euler and Daniel Bernoulli, we know that rods have special mechanical modes with natural frequencies in odd ratios, and that can be excited according to mode shapes. This phenomenon creates a feature space of the consequences of an impact. Since the model response unambiguously encodes the initial conditions, a simple machine learning algorithm could quickly solve the inverse problem. We also hypothesized that the feature space was directly encoded in a putative neural response. But that is left for future research. In the meantime, we investigated the neural correlates of the task of locating an impact on a tool. Luke Miller had the idea of an evoked potential paradigm resting on the observation that brain activation becomes suppressed with repetitions of identical sensory inputs. If the brain was decoding location, then activation should increase with novel impact locations. This response was actually observed, but what was missing were good controls. Fortunately, Alessandro, who is close to clinical practice, knew of a deafferented patient who had no proprioception but spared touch. This volunteer could also do the task and had similar neural correlates. A second control was arranged by directly touching the arm of volunteers, and again, the neural correlates were similar, suggesting that the tool tactile input was processed in a similar way as an arm tactile input, including the time course of evoked potentials. Despite the dramatic differences in the peripheral inputs, this task engaged similar cortical networks. The boundaries of somatosensory processing are a key theoretical question that has practical, real-world implications, as in the design of prosthetic limbs. Thank you.